On March 4, 1991, a Douglas DC-9 operated by charter carrier Transmeridian Airlines touched down at Denver's Stapleton International Airport at 7:23 in the evening, Mountain Standard Time. The aircraft had departed from Las Vegas McCarran International earlier that afternoon, carrying 112 passengers and a crew of 6. Flight logs recorded a routine sector, weather conditions were favorable, and the landing was unremarkable. The crew disembarked, passengers collected their luggage, and ground handlers began the standard turnaround procedure for the aircraft's next scheduled departure. What should have been an entirely ordinary commercial flight became the subject of a Federal Aviation Administration inquiry that remained classified for nearly 2 years. The reason was not mechanical failure, pilot error, or any safety violation that typically triggers such investigations. The reason was a discrepancy in the aircraft's arrival time that could not be reconciled with any known navigational, meteorological, or operational variable. According to every instrument aboard the aircraft, every timestamp recorded by onboard systems, and every entry in the flight management computer, Transmeridian Flight 914 had arrived in Denver 37 minutes before it departed Las Vegas. To understand what happened, you have to begin with what the flight was supposed to be. Transmeridian Airlines was a small charter operator based out of Oakland, California. It had been in operation since 1986, providing contract flights for tour groups, sports teams, and corporate clients. The company operated a modest fleet of older narrow-body jets, including 3 Douglas DC-930 series aircraft purchased from a regional carrier during fleet modernization. These were reliable workhorses, well-maintained and fully compliant with FAA airworthiness standards. On the afternoon of March 4, 1991, one of these DC-9s was assigned to operate a charter flight from Las Vegas to Denver, transporting a group returning from a weekend conference. The aircraft in question was registration number November 72 Tango Mike. It had accumulated just over 41,000 flight hours since entering service in 1978. Maintenance records showed no outstanding squawks, no deferred items, and a clean bill of health following its most recent A-check 3 weeks prior. The captain assigned to the flight was a former Air Force transport pilot with over 9,000 hours of total time, including 2,200 hours on type. His first officer had logged 6,800 hours and had been flying the DC-9 for 4 years. Both crew members were well rested, current on all training requirements, and had flown together multiple times in the previous month. Flight 915 was scheduled to depart Las Vegas at 5:45 in the afternoon, local time. The planned route was direct, following Airway Victor 105 northeast across the desert before intercepting the jet route structure toward Denver. Total flight time was estimated at 1 hour and 32 minutes, accounting for prevailing winds and standard climb and descent profiles. Fuel load was calculated for the planned flight time, plus FAA-mandated reserves, with an additional 20 minutes of contingency fuel added per company policy. Total fuel on board at departure was 14,200 pounds. The crew arrived at the aircraft at 4:50 in the afternoon. Pre-flight checks were completed without incident. Passengers began boarding at 5:15. The captain filed the flight plan electronically through the FAA's automated system, listing an estimated departure time of 5:45 and an estimated arrival time of 7:17 Mountain Standard Time. Weather briefings showed clear skies along the entire route, light winds aloft, and no significant convective activity. Surface temperatures in Las Vegas were 68 degrees Fahrenheit. In Denver, temperatures were 39 degrees with calm winds and visibility exceeding 10 miles. At 5:37, the captain contacted Las Vegas ground control and received clearance to taxi. The flight was cleared to Denver via the filed route, instructed to climb and maintain flight level 310, and given a discrete transponder code of 4263. The crew read back the clearance without error. Ground control handed them off to Tower at 5:42. Tower cleared Flight 912 for takeoff from runway 25 left at 5:44 and 30 seconds. The aircraft began its takeoff roll at 5:45 and 8 seconds, lifted off 18 seconds later, and was handed off to departure control at 5:46. Everything up to this point was standard. Departure control instructed the flight to climb to flight level 230 and proceed on course. The crew acknowledged and began their climb. At 5:51, the aircraft leveled at 23,000 feet and was cleared to continue climb to the filed altitude of 31,000 feet. At 5:58, Flight 914 reached its cruising altitude and established contact with Los Angeles Air Route Traffic Control Center, which had jurisdiction over that portion of airspace. The controller acknowledged the flight, confirmed its position, and issued no further instructions. The flight proceeded on course. At 6:04, Los Angeles Center handed the flight off to the next sector. The crew checked in, reported level at flight level 310, and received acknowledgement. At 6:19, the aircraft crossed into Denver Air Route Traffic Control Center's airspace. The crew made initial contact, confirmed their altitude and heading, and were told to expect lower altitude in approximately 30 miles. At 6:22, Denver Center cleared the flight to descend to flight level 240. The crew read back the clearance and began their descent. Up until this moment, every communication, every position report, and every radar contact had been routine. The flight was tracking exactly on its filed flight plan. There were no deviations, no requests for weather avoidance, and no abnormal radio transmissions. The aircraft was on time, on altitude, and on course. At 6:27, a radar controller at Denver Center noticed something irregular. The data block associated with Flight 914's transponder code momentarily flickered on his scope. The altitude readout blinked once, then resumed normal display. This was not unusual in itself. Transponders occasionally experience brief signal interruptions due to atmospheric conditions, momentary loss of interrogation, or minor electrical fluctuations. The controller made a mental note, but took no action. The flight was still displayed, still on course, and still descending as instructed. 30 seconds later, the data block disappeared entirely. A transponder dropout is a more significant event, but not uncommon in areas of poor radar coverage or high terrain. The controller waited for the target to reappear, as they typically do within 10 to 15 seconds. It did not. He attempted to raise the flight on the assigned frequency. Transmeridian 914, Denver Center. No response. He tried again, waited 5 seconds, then switched to the emergency frequency. Transmeridian 914. If you read Denver Center, squawk ident. There was no reply, and no transponder return showing an ident function. The controller began to follow lost communication procedures. He checked for any nearby aircraft that might have visual contact. None were in the immediate vicinity. He alerted his supervisor, who moved to his station to observe. At 6:29, the controller contacted approach control at Denver Stapleton to advise them of a possible lost comm situation. Denver Approach acknowledged and began monitoring their own radar displays. At 6:31, the controller at Denver Center saw the data block reappear on his scope. The aircraft was at 22,000 feet, descending and on course. The transponder was functioning normally. The altitude encoder was functioning normally. The aircraft appeared exactly where it should have been based on its last known position and flight profile. The controller immediately attempted contact. Transmeridian 914, Denver Center, radio check. The response came through clearly. Denver Center, Transmeridian 914, We read you 5 by 5. The controller asked if the crew had experienced any radio or transponder issues. The captain replied that they had not. All onboard systems were operating normally, radios were functioning, and the transponder had remained on the assigned code throughout the flight. The controller acknowledged and advised the crew that there had been a momentary loss of radar contact. He asked the crew to verify their current altitude. Descending through 22,000 for 240, the captain replied. The controller noted that the altitude was consistent with what his radar displayed. He cleared the flight to continue descent to 16,000 feet and to contact Denver approach on the next frequency. The crew read back the instruction and checked in with approach control at 6:33. Approach control issued vectors for the arrival and cleared the aircraft to descend to 12,000 feet. The flight continued its approach without further incident. At 6:48, Flight 914 was cleared for a visual approach to runway 35 right. At 6:51, the aircraft was cleared to land. It touched down at 6:53 and 16 seconds, rolled out, and exited the runway at taxiway Echo. Ground control cleared the aircraft to taxi to the gate. It arrived at stand 12 at 6:58. Engines were shut down at 7:01. Passengers began deplaning at 7:06. The crew completed their post-flight duties, secured the aircraft, and proceeded to the crew lounge. They filled out the standard flight paperwork, noting no mechanical discrepancies, no abnormal fuel consumption, and no unusual occurrences during the flight. They listed the actual block time as 1 hour and 13 minutes, slightly faster than planned due to favorable winds. They noted the actual fuel remaining at shutdown as 6,200 pounds, which was consistent with the planned fuel burn plus reserves. Nothing about the flight, from the crew's perspective, had been unusual. The following morning, a dispatcher at Transmeridian's Operations Center in Oakland received a routine data download from the DC-9's flight management system. The FMS was a relatively basic unit compared to modern avionics, but it recorded key flight parameters including departure time, arrival time, waypoints, and fuel calculations. The dispatcher opened the file to verify the times for billing and scheduling purposes. The FMS recorded the departure time from Las Vegas as 17:45:08 local time. This matched the crew's logbook entry, and the towers recorded takeoff clearance. The arrival time at Denver, however, was listed as 19:08:14 Mountain Standard Time. The dispatcher immediately noticed the discrepancy. According to the flight plan and the crew's report, the aircraft had landed at 18:53. The FMS time was 15 minutes later. He assumed it was a data entry error or a malfunction in the aircraft's clock synchronization. He made a note to have maintenance check the system during the next overnight service. He forwarded the flight data to the company's records department and moved on to other tasks. 2 days later, the FAA's Flight Standards District Office in Oakland received a routine submission of flight data from Transmeridian as part of a compliance audit. An inspector reviewing the data for Flight 914 noticed the same time discrepancy the dispatcher had seen. Unlike the dispatcher, the inspector had access to ATC recordings and radar data. He cross-referenced the FMS arrival time with the recorded ATC communications and the radar timestamps from Denver approach. What he found did not resolve the discrepancy, it deepened it. According to the audio recordings from Denver approach, Flight 914 had contacted the controller at 18:33 Mountain Standard Time. According to Denver Center's radar logs, the aircraft had reappeared on radar at 18:31 after a brief loss of contact. According to the tower's records, the aircraft had touched down at 18:53:16. All of these times were consistent with each other and with the crew's written report, but the FMS disagreed. The FMS insisted that the aircraft had not landed until 19:08:14. The inspector requested the complete data download from the aircraft's onboard systems. This included not only the FMS, but also the digital flight data recorder, which continuously logged dozens of flight parameters, including time, position, altitude, airspeed, engine performance, and control inputs. The DFDR was retrieved from the aircraft during a scheduled maintenance check on March 9th and sent to an FAA-approved data analysis facility in Oklahoma City. The results arrived on March 15th. The DFDR corroborated the FMS. According to the recorder, the aircraft had touched down on runway 35 right at Denver Stapleton at 19:08:14 Mountain Standard Time. The recorder showed a continuous flight profile from takeoff in Las Vegas at 17:45:08 to landing in Denver at 19:08:14, with no gaps, no interruptions, and no anomalies in the data stream. Total flight time, according to the recorder, was 1 hour, 23 minutes, and 6 seconds. The inspector now had two irreconcilable sets of data. On one side, every external record, ATC audio, radar logs, tower records, and ground handling timestamps showed that the aircraft had arrived at 18:53. On the other side, every internal record, the FMS and the DFDR, showed that the aircraft had arrived at 19:08. The difference was exactly 15 minutes. The FAA opened a formal inquiry on March 18th. The scope was initially limited to a possible instrumentation malfunction or data corruption. Investigators requested maintenance records for the aircraft's avionics systems, including the FMS, the DFDR, and the aircraft's master clock, which synchronized time displays in the cockpit and fed time data to the recorders. Maintenance logs showed that all systems had been functioning normally. No faults had been logged, no circuit breakers had been tripped, and no anomalies had been reported by the crew on Flight 914 or on any subsequent flight using the same aircraft. The aircraft's master clock was tested on March 20th. It was found to be accurate to within 2 seconds of coordinated universal time. The FMS was tested. It was functioning correctly. The DFDR was examined by technicians at the National Transportation Safety Board's laboratory in Washington. The data was intact, uncorrupted, and internally consistent. There was no evidence of a recording error, a playback error, or a software malfunction. At this point, investigators began to focus on the possibility of a deliberate alteration. They interviewed the crew. Both pilots were adamant that they had landed at the time recorded in their logbooks and confirmed by ATC. They had not adjusted any clocks, had not tampered with any avionics, and had not experienced any anomalies during the flight. Their statements were consistent with each other and with their written reports. Both men were polygraphed at their own request. Both passed. Investigators then examined the possibility of an external tampering with the aircraft's systems while it was on the ground in Denver. This theory was quickly discarded. The aircraft had been under continuous observation by ground personnel from the moment it arrived at the gate until it departed on its next flight. Security footage from the terminal showed no unauthorized access to the aircraft. On March 27th, the FAA took the unusual step of interviewing passengers from the flight. 12 passengers agreed to provide statements. All of them remembered boarding in Las Vegas in the late afternoon, flying for what seemed like a normal amount of time, and arriving in Denver while it was still light outside. Several passengers noted the time on their wristwatches when they deplaned. 3 of them had written down the time in travel logs or day planners. All 3 recorded times between 7:05 and 7:10 in the evening, which was consistent with the ATC and ground handling records. None of the passengers reported anything unusual during the flight. There had been no turbulence, no strange noises, no unusual announcements from the crew, and no moments when the cabin lights had flickered or the aircraft had shuddered. The flight had been, in every subjective sense, routine. The FAA's inquiry now faced a paradox. External observers, air traffic controllers, tower personnel, ground handlers, and passengers all agreed that the aircraft had arrived at approximately 6:53 in the evening. Internal systems, designed specifically to be tamper-proof and highly reliable, insisted that the aircraft had arrived at 7:08 in the evening. Both sets of records were consistent within themselves. Neither could be explained away as simple error. On April 2nd, investigators made a request to the U.S. Naval Observatory, which maintains the master time standard for the United States and provides precise time signals used by aviation systems worldwide. They asked for any record of time signal anomalies, GPS irregularities, or synchronization errors on the afternoon of March 4th. The observatory reported none. Time signals had been stable and accurate throughout the day. Investigators then examined weather data, solar activity, and atmospheric conditions. March 4th, 1991 had been a quiet day geophysically. There had been no solar flares, no unusual ionospheric disturbances, and no significant geomagnetic activity. Weather along the flight path had been clear and calm. There was nothing in the environmental record that could have affected the aircraft's instruments or the ground-based radar systems. On April 10th, the FAA requested data from other flights that had been operating in the same airspace at approximately the same time. 6 other commercial flights had been within 50 miles of Flight 914's route during the period in question. All 6 had filed flight plans, all 6 had been in continuous radar contact, and all 6 had reported normal operations. None of their onboard recorders showed any time discrepancies. None of their crews reported any anomalies. The investigation reached an impasse. There was one final detail that had not yet been fully examined: the brief loss of radar contact at 6:27. Controllers had dismissed it as routine, but in light of the time discrepancy, investigators revisited the radar data. They requested the raw radar recordings from Denver Center for the period between 6:26 and 6:32. The recordings showed that Flight 914's transponder signal had disappeared from the scope at 18:27:14 Mountain Standard Time. The signal had reappeared at 18:31:02. The duration of the dropout was 3 minutes and 48 seconds. During that time, there had been no primary radar return from the aircraft, which meant that even without a transponder, the aircraft itself had not been reflecting the radar beam. A primary radar return is a passive echo. It does not require a transponder. It reflects off the physical structure of the aircraft. For a DC-9 at 23,000 feet to produce no primary return, it would have to either be outside the radar's range, be below the radar's coverage floor, or simply not be there. Investigators calculated the radar's theoretical coverage at that altitude and distance. The aircraft should have been well within range. They examined the possibility of a radar malfunction. Denver Center's equipment had been functioning normally throughout the day. Other aircraft in the same vicinity had been tracked continuously. Only Flight 914 had vanished. The question was put to the crew during a follow-up interview on April 18th. Both pilots were asked if they remembered anything unusual happening at approximately 6:27 in the evening during the flight. They were not told about the radar dropout. They were simply asked to recall any events, sensations, or observations during that specific time window. The first officer thought for a moment, then said he remembered a brief instance of what he described as radio squelch. He said that for a few seconds the communication radios had gone silent, but he had assumed it was a momentary gap in transmissions. The captain did not recall the squelch, but he did remember looking at the navigation display and noticing that the GPS position had briefly frozen before updating normally. He said he had attributed it to a satellite handoff or a momentary processing delay. Neither crew member had considered the event significant enough to mention in their post-flight report. Investigators asked if there had been any physical sensations during that time. The captain said no. The first officer paused, then said that he might have felt a slight vibration, but he wasn't certain, and he couldn't distinguish it from normal airframe noise. The FAA concluded its inquiry on May 6, 1991. The final report was 11 pages long. It documented the time discrepancy, the radar dropout, and the crew's statements. It noted that no mechanical cause, no instrument malfunction, and no procedural error had been identified. The report concluded that the discrepancy was unexplained and recommended no further action. The file was classified as administratively closed and marked for limited distribution. Transmeridian Airlines was informed of the findings, but was not required to take any corrective action. The aircraft, November 7 2 Tango Mike, remained in service for another 6 years before being retired and sold to a cargo operator in South America. It was eventually scrapped in 2003. The crew continued to fly for Transmeridian until the company ceased operations in 1995. Both pilots went on to fly for major airlines. Neither spoke publicly about the incident. In 1993, a researcher at the Massachusetts Institute of Technology, who had been studying anomalies in aviation data, obtained a copy of the FAA's inquiry report through a Freedom of Information Act request. He published a brief paper in an aviation safety journal discussing the case as an example of instrumentation reliability issues in older aircraft. The paper did not offer an explanation. It simply noted that the event remained unresolved. There were no follow-up studies, no additional investigations, and no subsequent incidents involving the same aircraft or crew. Flight 9 Morph-Tier became a footnote in a rarely read technical journal, a file in an FAA archive, and a memory for 118 people who flew from Las Vegas to Denver on an otherwise unremarkable Monday in March. But there is one element of the case that was not included in the FAA's report, because it was discovered after the inquiry had closed. In June of 1991, a ground engineer at Denver Stapleton, who had been part of the team servicing the aircraft on the night of March 4th, submitted a routine fuel audit as part of the airport's environmental compliance reporting. The audit included fuel uplifted, fuel remaining, and calculated fuel burn for all aircraft serviced that day. The engineer noted that the fuel remaining on Flight 914 when it was serviced that evening was 6,200 pounds, which matched the crew's report. But when he calculated the fuel burn based on the flight time and the known fuel consumption profile of a DC-9 at cruise, the numbers did not align. According to his calculations, the aircraft should have burned approximately 5,800 pounds of fuel for a 1 hour and 13-minute flight. The crew had reported a fuel burn of 8,000 pounds. The difference was 2,200 pounds. That discrepancy represented approximately 18 additional minutes of flight time. If you follow aviation mysteries and unexplained incidents, subscribe for future investigations.